Jeff with Lenco Diesel Performance and LDP Machine here for another Tech Tip Tuesday. This one is a pretty highly anticipated one. It's gonna be a two-part video series here. Degree in camshaft and check and valve the piston clearance. A lot of people always ask, I know there's a lot of confusion out there, so we're gonna go ahead and show you the right way, the way we feel is the right way to degree a camshaft and then check valve the piston. I'm going to show you some other things along the way that are going to aid in valve the piston clearance and things that need to be checked. First thing, we got a 12 valve Cummins here. This is a used engine. It's not an engine we built. Customer brought this to us. We sold him parts, and he's been putting this together for a while. And wanted to make sure his combo worked, and he was trying to check valve the piston and had some issues, didn't have the right tooling, so he brought it up here for us to do. So in order to do it properly, we wanted to degree the camshaft. So we pulled the head back off, and we're kind of starting over and checking this thing right for him. So this is a good one to use for this video because this is practical, because a lot of guys are gonna be doing this in a truck, especially Cummins guys. So we've got a used engine. We're gonna have full height pistons, not reduced height pistons. And it's just very practical. It's on a stand, but it's no different than if you did it in your truck. So that's why this one works good. First things first, in order to degree cam and or check valve the piston, there's several tools that you have to have. Number one will be a degree wheel. You see, we use the Moroso Pro wheel. It's a nice wheel. Last I looked, I think they're around $100. We also, if you look over there on the wall, we got that big billet aluminum 24-inch. That's super accurate. The larger diameter you get, the more accurate it is. So that's what we have that for, like big gas builds. The Pro wheel's great. We use this on, use them for years. Before I had that, a more basic wheel, this one from Summit, lots of places sell these. I think this is a 12-inch wheel. It does the same job, just not quite as accurate because the diameter's smaller. But as long as you use it right, perfectly fine. I've had this one for years. This was my first degree wheel that I ever had. We hogged out the holes to get two 12mm bolts on the Cummins. And then, we slotted these holes that works on a power stroke with like an ATI damper. So every now and then we still grab this for some oddball stuff. We typically use the Pro wheel. Now, as you see, we got all these holes notched in here. That's because most of your wheels you're gonna buy are designed for a gasser. So usually they've got one center hole, and then they sell different size pilots to center them up. So us diesel guys, got to get creative. On this wheel, you can't see it because it's already bolted on, but we went ahead and drilled in the mill. We drilled the 4-bolt pattern for a Cummins, so it fits nice. It's concentric, when we rotate it. And then we always use this a fleece barring tool, which we went in on the backside and we notched it out for dowels. So whether it's a common rail or if it's got fluid amper drill pins, we notched them out for dowels. And then we also have this sleeve we cut down on the backside that helps space it out, works good. So easy stuff to put together, but you have to have a way to mount it secure where it's not gonna turn on you. And ideally, it needs to be, concentric so it's not rotating on an axis. So for a Duramax, almost everybody's got a couple old balancer washers laying around. So we threw one in the lathe and turned it down and put a shoulder, and then that shoulder centers it, and then we use the other one to go on the front side. So nice and easy. And then, like I said, on the power stroke stuff, we bolted on. So a degree wheel and a way to mount it is an absolute must. And then the next thing would be a pointer or indicator. Most people use a piece of wire or actually buy a pointer. We use a laser, it works awesome. We got a flexible, it's a dial indicator mount, but the same size as a laser pen. So it's more accurate. This laser is more accurate. As you'll see when we start getting into this, that you got the red laser, it hits the white, it really illuminates it. We're all the way out the very end, and no matter how you view it, it's gonna be the same. Whereas the pointer, depending on your angle you're viewing at, can throw you off a half a degree. So it's very accurate, but not necessary. You can use a coat hanger or a piece of, mechanics wire or baling wire and do it if you do it right. Next thing, you need some form of a piston stop. You can rig something up with some flat metal or angle iron you have laying around. If this is like kind of a one-time deal, it's not hard to make something. We like a piston stop that goes all the way across the cylinder and bolts down on both sides, because your piston is going to rock. If you got, especially like if you're doing this in a truck and you've got 6 or 7 or 8 thousandths piston to wall clearance. If you only catch one side with the piston stop, you got a tendency to rock. So then the more pressure you put on your ratchet as you're turning, you can change it by a degree or more. So by doing the piston stop all the way across, you take the rock out of it. It's very firm, works good. But some form of a piston stop is necessary. You cannot accurately do this with the cylinder head on, with putting a screwdriver down the cylinder. You're not accurate at all. When you're trying to be even more accurate than this, you can use the dwell method, where you use a dial indicator. You run the piston up the dwell, you go back X amount of degrees, and then you go clockwise past dwell the same amount of degrees, and then you average it and split it. Some guys prefer that method, but a good positive piston stop works great. So that's how we do them. Then you also need a good dial indicator stand. You don't have to have something this fancy or large. This has a very firm, base on it, so I like to use it because it's accurate. But you need a dial indicator, and then you need some way to get down to the lifter. You can put a push rod in there as long as you have something to guide it and keep it where it's not rocking on you, and read off that, but that's obviously not very accurate. I tried it like that when I was young, and you can do it, but it takes a lot of patience and it's not the most accurate. So what I did years ago was got a dial indicator extension, and then cut the end of a Cummins push rod off, slid it inside there, tacked it on. Now this goes all the way down there, goes right into my dial indicator, and it works great. You just gotta make sure that you're nice and straight within the travel of your tappet. So like I said, you have to have some way to get down straight to the tappet or lifter. Something else to mention while we're here. So if you are doing this on a 12 valve and you're locating TDC, this is an excellent time to check your timing pin to make sure it's accurate. Usually it's not, especially if you overhauled it and you pulled this off to change the seal. It's definitely not accurate because there is a lot of adjustability in these. So when you got your piston stop and you locate TDC, you remove your piston stop, roll your degree wheel to TDC, and then you can go ahead and set your timing pin. So like I said, if it's 12 valve, good time to do that. So that pretty much covers the tools. We're gonna go ahead and jump into it. So to save time, we already mounted our degree wheel. We got our piston stop on here. We're gonna go ahead and show you the proper method for locating TDC. So if you wanna come over here on this side. So it doesn't matter if you go clockwise or counterclockwise first. Out of habit, I always go clockwise. So, and we have already set this, but we're gonna show you how to do it. So we're gonna roll over clockwise until we firmly hit our piston stop. And we note the degree wheel. We are just a hair over 7 degrees on our degree wheel. So now we're gonna go the opposite direction of travel. We're gonna bring that piston up until it hits our piston stop and note the position. Okay. And we are just a hair over 7 degrees. So it takes a little playing around with. You can see how the laser makes it a lot more accurate, especially here if I get right on, let's say 10 degrees. 10 degrees is a very important number that you'll see when we're doing valve to piston. And you see how nice that illuminates. So way more accurate than a pointer, but again, whatever method you want to use works as long as you're doing it right. So I'm gonna go ahead and roll this back over, and we're gonna remove our piston stop because we have our degree wheel set. So, and what we're doing there was we're coming up both directions, hitting our piston stop, and then you would move your pointer and keep checking it until you were the same before and after TDC on each side. And then obviously you remove it. If you go to 0 degrees, that's true TDC. So that is the reason for doing that. So let's go ahead and pop this off of here. Another tool that I didn't mention, it's not absolutely necessary, but it's a good idea if you're building an engine, you need to be doing this. And it's good to note piston protrusion when you're checking valve to piston, especially if it's a combination you may or may not do again, or if you're putting a lot of Duramax or Cummins engines together, you always want to note protrusion. So we've got this is a sleeve height gauge. There's several different tools you can use, but the sleeve height gauge works great for checking protrusion. So we'll go ahead and do that here in a second. And again, like I said, protrusion isn't necessary for degreeing a camshaft, but it's good to note. And you know, we go back all the time and pull out notes on other builds and look at protrusion, look at valve recession to see where clearance was. So now we're gonna go ahead and we're gonna roll this up until we're on 0 degrees, and then we're gonna check protrusion. Okay, right there. So you can see how that indicates real nice and bright, dead center on 0. So the gauge here, I'm gonna make sure going off the deck that it's 0. And you always gotta keep in mind if you have a ridge or anything, you know, that's gonna throw it off. So I always kind of check it multiple places. And we're about half a thou off. Okay, so we're 0, lift our pointer, come over on the piston, and we have 25.5 on piston protrusion. So we're gonna document that. Okay, so like I said, that's more for later use and for your own knowledge, but a lot of cam manufacturers, like Hamilton, we use Hamilton over Cummins builds, and Hamilton, you know, will give you this information. If you have no more than 25 thousandths piston protrusion and at least 55 thousandths valve face depth or valve recession, then they're a 188-220 or a 178-208 is a drop-in. So that's why it's important to check protrusion. And then while we're set up right here, we want to show you the cylinder head. Valve recession is very critical to valve the piston clearance. Depending on what machine shop you're using, if they're not well versed in diesels, they'll probably just go off or rebuild their spec. So there could be a 50 thousandths range on valve recession. So it's very important that you check it. We do a minimum of 55 on our 12 valves. We try to get all of them right at 55, but a minimum of 55. And we've seen a lot of times where this is more of an automotive, you know, gas machine shop did a head for somebody, maybe had 38 or, you know, low 40s, and they had issues. So this head was done by our machine shop, which is why we wanted to check it. We've already gone through and checked every one of them. I'll just show you this one real quick. So we, you know, zeroed our gauge and we are dead on at 55. So these guys did a pretty good job. 56, 55, but then you get like 51, 53, 51. Should be fine. You're talking a couple thousandths, but if you're tight, it's good to go and document this and you check number 1. And if you're like 50 thousandths, you might have some issues here. So again, that's good to document and note that. If you don't have the recommendation by your cam manufacturer on valve face depth, you need to cut the seats or grind the valves and get it fixed. Make sure it's addressed. Okay, so now we're back to here. We're on TDC. So we've located everything with our degree wheel. We're ready to start measuring. So one important thing is make sure that you're on, before you go try to zero your indicator, you want to make sure that you're on, that you're on the back side of the valve, that you're not on exhaust stroke. So you can look down and see the tappets are both all the way down. So we're going to put our indicator on. And I use this digital one, it's really handy. You don't have to have anything this fancy. A regular indicator works, and there's times where I get frustrated using them still. Nothing wrong with it, just it's easy to read, I like it, but you don't think you have to have real fancy stuff to do this. So, as I said, the most important thing is getting set up really nice and true with the travel of the lifter, so that that your indicator doesn't stick at any point and not come down and give you an accurate reading on the backside. And there is, you can have something with the spring that'll help the indicator stay preloaded on the tappet, but as long as you do it right. There's nothing wrong with doing it this way. That's why it's important to get the angle right. And if I was building this engine, we would have the tappet cover off and I would have a pump on it. Make this even easier, but common rail, you don't have that luxury, so you just look down through the hole and make sure you're centered, and then we're going to check it and make sure we're nice and lined up on it. And then also too, you have to make sure you have plenty of travel once you mount it. We need at least 300 thousandths of upward travel. We've got more than that, but make sure you don't, that you check that beforehand. So I always like to lift it up and let it down and see if it naturally goes back into the cup of the tappet or lifter. And this one isn't bad, but you can tell it's kicking off the side a little bit. So we'll loosen it up, make an adjustment, check it again, and that definitely feels better. So okay, zero indicator. We're gonna roll around and make sure that we are on TDC compression stroke, which we're not. We were on exhaust, so. All right, so zero is what we're doing. We're making sure we're on the back side of the lobe, and then we're zeroing out our indicator. I want to make sure, yeah, we still have travel downward. So, okay, so we're zeroed. We know we're getting ready to come up on lift. So before we get into this, I need to explain the two different methods for checking cam timing or degree in your camshaft. The one you hear most commonly is centerline. Centerline's the easiest to check, and it's the easiest to relate to people and give a number. The more accurate measurement is checking cam timing by intake opening and intake close at 50 thousandths. And you can check exhaust too, but as long as the cam was ground right, if the intake's on, the exhaust is going to be on. So you could go through and check every whole intake and exhaust if you didn't trust your cam manufacturer. But typically in the industry, you check intake opening at 50 thousandths and intake close at 50 thousandths, which is more accurate. We check both. Check center line, so we have the number, but we also check cam timing. And you have to get this information either from a cam card, or most people are going to put, at least going to put center line out there, but you're going to need a cam card to get the timing. So we're going to go through and check it, and then I'll show you the cam card, and we'll record everything. So again, this is degree in the cam. We're on 0 on our indicator, and we're gonna get ready to come up on intake open. So we're gonna turn the degree wheel very slowly. So when we hit 50 thousandths opening, we're gonna stop. We're gonna record our degree wheel measurement, okay? So we've got our paperwork ready. So let's go ahead and roll this over and watch that indicator. We're looking for 50 thousandths. So we're just starting to open, and it'll go pretty quick. It's a pretty aggressive lobe, so come up nice and slow, because if you go past it, you gotta go back at least 30 degrees to take the gear lash out. So the longer ratchet is beneficial. There's times where I'll put my 24-inch ratchet. Short ratchet might turn it easy, especially on a fresh build, but the longer the ratchet, the more accurate, easier it is to control. So we're dead on at 50 thousandths, and we are at 4 degrees. So I can already tell you we're a degree off, but we're at 4 degrees on our intake opening. So I'm gonna make note of that. We're 4 degrees before TDC, so -4. Now we're gonna come up, we're gonna measure and verify max lift compared to our cam card, and then we're gonna go past max lift to 50 thousandths before closing. And this is where the digital indicator's handy. You don't have to watch and count your turns, so it's a lot easier to not go past it. So we're gonna come up, and should be about 278 thousandths max lift on this Hamilton 188-220. Well, 280, okay, maybe I was wrong. All right, it's 330. Okay, 307. So I was probably thinking of a 178-208. So 307, we're gonna come back down. And again, if you had a normal dial indicator, you're gonna have to count your number of turns, which is done by 100,000ths. So you would have been at 3. So we're coming back down, we're on the back side of the lobe. It's a good idea to watch your indicator to make sure it is truly traveling down. And we're going to 50 thousandths. Okay, 50 thousandths. And on the degree wheel, this one's marked for valve timing, use black. So we are at 11, 12, 13. So 13 degrees. So I'm going to document that, 13 degrees. And then I am going to go to my cam card. And Hamilton's providing me with this information. I believe it's still on their website. You know, any good cam manufacturer is not going to have a problem providing you with this information to make sure you're installing it right. 188, 220. Intake timing, -5, so 5 before, and 13 on closing with a 99 degree center line. So I've got -4 and 13. So we're matching on our closing. We're showing a degree early on our opening. So I'm gonna go past, get on the back side of the cam lobe and make sure our indicator comes back to 0. More than likely, you know, we got off just a little bit to be 1 degree off on opening, but matching on closing. So we're gonna go around and double check ourselves. It's not uncommon to be a couple thousandths off. And we're only 2 thousandths, so that's gonna explain. Let's see, if I help it, it's 1 thousandth. So that's pretty accurate. So 4 degrees before on our opening, 13 on our close. So we're very close to our cam card. So now is where we're gonna check our center line and see where we're at. So to check center line, it's very simple. You go to max lift, you zero your indicator, you roll your engine counterclockwise backwards till your indicator goes down at least 100 thousandths. And then you're coming back to 50 thousandths before max lift. The reason you go backwards at least 100, again, is to get the lash out of your gear train. So you bring it up to 50, you note your reading on your degree wheel, you go to max lift, and you go to 50 thousandths on the back side of the lobe, document your reading, add them together, divide it by 2, and that's your center line. So we're gonna have to go backwards, we're gonna get to max lift, and go quite a ways past it and come back up. And last time we had 307, dead on 307, so we know everything's good on our indicator. So I'm going to come back up and hit 307. Okay, see, so now we're a half a thou, but see how long it dwelled there? That's why you go 50 each way. Okay, so we're gonna stop right there. So just like with piston dwell, your camshaft, especially on a flat tappet, has quite a bit of dwell where it holds that valve at max opening. So you're zeroing at dwell and you're going 50 before and 50 after because you're getting past the max lift where it's dwelling and checking on each side of the lobe. So it's a lot of people, you know, regard center line is not a very accurate method. That's why we check both ways. So we check the cam card for opening, closing, and center line. But center line gets you in the ballpark pretty good as long as it's done right. So now we're going backwards. So we have at least 100 thousandths downward travel. So 138. So we're coming back up to 50. Again, nice and slow. Okay, so 50. So we are at 58 on our degree wheel. So come up, we should be 0 when we hit max lift. Bam. And then we come down to 50 thousandths downward travel on the back side of the lobe. Okay, 50 thousandths. So we come over here, we're using the white numbers. So we're 137.5. I do this all the time. I degree every Cummins cam, and we use Hamilton cams in all of them, so I know all these numbers. I know we're right in the ballpark. 58 plus 137.5, right? 58 plus 137.5. So we're adding both measurements together, dividing it by 2. 97.75, so 98 degrees. So our center line is 1 degree advanced from the cam card. Being within a degree on the average build is fine, as long as your valve to piston clearance is okay. When you're degreeing a cam, advancing a camshaft will bring your power band down, and retarding your cam timing will bring your power band up in RPM. So for the average guy, you're putting up 188-220 is a pretty large camshaft, which you want a large cam at 12 valve is a 2 valve head. They need all the help they can get flow and air. So you're putting a big cam, by advancing it that 1 degree, you're probably realistically not going to notice a difference, but on a dyno you would see your power band move down a little bit. That's what most people are going to want. So 98 degrees, we're going to stick with that, and we're going to check our valve to piston. As long as we're good on valve to piston, we're fine. I know Colt cams, I think they run a 98 degree center line on most of their drop-in cams, and they tell you plus or minus 1 degree on center line. So again, you see the more accurate way of checking it is by checking opening and close, and we were within a degree on opening and we were dead on close, and then when we're checking our center line, we're within a degree. So if this was a truck pulling engine, we might tweak that. Sometimes we'll run a smaller cam and then retard it to bring the power band up, like in a drag race application. Usually on street stuff or work stock 2.6 pullers, a lot of times we are advancing the cam. We're putting a bigger cam to get the airflow, and then we're advancing it to bring the power band down. So I'm happy with the 98. We'll check our valve to piston, which will be another video. We'll put that out next week. We'll check our valve to piston, and as long as our intake and exhaust are fairly close to each other, minimum of 50 thousandths on a Cummins, and as long as they're close to each other, that 98's great. If you've seen, let's say we had 97, we were advanced 2 degrees, then you're going to expect to see you're going to have, if you advance in it, you're going to have your intake opening sooner, so your intake's going to be tighter than your exhaust, and then if you retard it, your exhaust is going to be tighter. So as long as we have a big spread and they're both within spec, we're good. So we're happy with that. So again, this is degreeing the cam. You might think, oh, I don't care about degreeing the cam, I just want to learn how to check valve to piston. In order to check valve to piston, you have to properly locate TDC, and you got to have a degree wheel. So, this is important. If you don't want to go through the trouble of degreeing the cam, let's say it's a Duramax and you think, well, I don't have any way of changing it, so I just want to check valve to piston. You still have to have a piston stop, you got to have a degree wheel, you got to do all the steps besides actually degreeing the cam. Every Cummins we build, unless it's a stock cam with the same gear, we degree them. We check valve to piston on every engine we build, but any Cummins, which we hardly ever do anything with stock cam, everyone gets degreed. And then, so if you want to get in right here, so on a Cummins, if you do need to change it, if you need to, move the cam, then you just put an offset keyway in. We keep them in stock for up to 5 degrees. So, and then and then another thing too, if you're doing this, fairly often, make sure you document everything really good. Like we wrote down our piston protrusion, we wrote down all of our measurements from degreeing the cam, and then if you had to move it, write down the part number of the keyway, and then redegree it, how much it moved. Next time you run into that, you go back and you just save yourself a lot of time. And then you also know what combination works. If you don't have your own machine shop, you can let the machine shop know what you need for recession based on what your piston protrusion is. So something else to keep in mind, head gasket thickness. Most people on 12 valve just automatically throw a 20 over head gasket, which depends what you're doing. Not always the best thing to do, but a lot of people do. If you have a 20 over head gasket and your protrusion on this 12 valve was 25 or less, then you wouldn't necessarily have to have 55 thousandths on your valve recession. So there's a lot of stuff that factors into it, which is why it's good to keep notes. you know, you can always go back and reference it. So if anybody has any questions, like with all of our videos, feel free to hit us up. You can email me at jeff@lincodieselperformance.com or give the shop a call. I'll be happy to help you out. And then, yeah, stay tuned. So next week we'll do valve to piston clearance. We'll get this head on here and we'll check valve to piston clearance. So keep an eye out for next week. Thanks.